today I'll be talking about the role of vitamin K in coagulation, which is clotting. Alex spoke today about vitamin K and how important it is in our body, so I'm not going to go through that and talk about it again. However, I'm going to focus on one pathway, which is clotting. Clotting is a very complicated pathway that goes into your body, but it's very, very important. It's very essential because it can prevent excess loss of blood, and it also involves cellular and protein component. The cellular component is platelets, and the protein component is coagulation factors. It also it goes into two steps. The first is primary hemostasis, and the second one is the secondary hemostasis. In the primary hemostasis, we have the platelets just forming blood. So if you see here, after you, this is not working, okay. After you get a cut in your skin or in one of the vessels, those white things go up there and form a plug. And after that, in the secondary hemostasis, we're going to have coagulation factors go through a very complicated cascade and form fibrins that make this whole clot very tight, so no more blood loss can happen. So the first thing that happens in the coagulation pathway is the activation of the platelets. After damage in the vessels happen in your endothelium, what will happen is some factors called VWF, and I don't know what they stand for, actually I forgot. They get exposed to the blood because normally they're covered by the vessels, and upon the exposure of those factors, more factors are going to be recruited to the cut site, such as factor A, collagen, and many others. Now, upon the release of those factors too, the platelets are going to bind to collagen that's produced in the site of the cut via collagen-specific glycoprotein receptors, and by adhesion, those platelets are going to be activated, and when they bind to the site, their granules are going to burst open, and they're going to produce they're going to release other factors such as ADP, serotonin, platelet activation factors, and this is going to recruit more platelets to go. So it's like a little cycle, and you can see it right here. And as I said, more platelets are going to be activated. Now the second step of the pathway is a complicated cascade, and it's actually two parts too. It's an intrinsic and an extrinsic pathway. I'm not going to go through the details of the pathway, but you can see it includes so many factors that need to be activated, and the main purpose of this cascade is to produce fibrin from 5-venogen, and in order for this to happen, we need all these other factors activated, and here where vitamin K come into play. Vitamin K involved in the carboxylation of glutamate residues in certain factors that I'm going to show you in a second. All these factors that are in boxes need to be activated by carboxylation that happen by vitamin K. Also, all these factors, and if those factors are not, if the glutamate of those factors, which are proteins, of course, are not carboxylated, we are not going to have this pathway happening. And if you notice, there are a lot of them, 1, 2, 3, 4, 5, and so many, and they're involved in both pathways. So to talk a little bit more about the specific reaction of vitamin K or vitamin K cycle, because it's essential, as I mentioned, in the activation of those factors here again. So vitamin K, after you ingest it, is going to be reduced by vitamin K epoxide reductase, and this reduced form of vitamin K is a factor that is needed by another enzyme, which is called vitamin K gamma glutamyl carboxylase, and this is the enzyme that converts or activates those factors by carboxylation of their glutamate. So if vitamin K is not produced, if it is not ingested, we cannot reduce it, and thus we cannot carboxylate those factors. At the same time, this is why we don't need so much vitamin K, because it keeps recycling in your body. So it's reduced and then oxidize and then again reduce and then oxidize. How much time? Oh, okay. So the last thing that I want to mention is an molecule called warfarin. This is something that is used now by the pharmaceutical industries in order to prevent clotting. So this molecule is going to block the action of epoxide reductase